Hey guys, welcome back. So in the previous video, we talked about why we need hashing and some common terminologies of hashing. Hope the idea was clear. In case if you have any doubt, please feel free to ask those in Q&A section and we will get back to you. In this video, we are going to talk about some sample good hash functions. So we'll take two examples. One will be when the input given by user is an integer, which is a very simple hash function, and second case will take when a user gives a huge string and we need to convert it into an integer. So let's get started. So the first sample hash function is a simple mod function for integer inputs. Now what does that mean? Let's see how the code for this looks like. Now let's say our hash function is smod, which takes input as an integer and returns the modulus 16 of the same number. Now what does that mean is, if for example we give a number 500, it divides it by the number 16 and finds out the remainder, which is 4 in this case, and prints the value numeric 4. Let's take one more example where we pass value 700 to this function. It once again divides 700 by number 16 and the remainder is 12. So it outputs numeric 12. So you see that number 500 gets reduced to number 4, 700 gets reduced to number 12, and so on. Now why we are reducing it? We are reducing it because we need a smaller integer value which we can associate with a cell in a hash table. So now that we have got numeric 4 in case of 500, we go to array cell number 4 and store numeric 500. Similarly, for number 700, we'll take cell number 12 in the hash table and save 700 there. So this is a very simple implementation of a hash function. Now let's take one more example whereby the input given by user is a big string instead of a number, which was in this case. Okay, so the next sample hash function is sASCII, which takes a string and an integer and then does some mathematical computation on those string and finally arrives at a smaller integer value. Now let's say we pass a string ABCDEFGH to this function. Now let's see what does this function do. Now if we go to the first line of this function, all it does is it declares a character array, then it references that array to the input string, then it declares some integer numbers. Now this is the heart of the entire function. So all it does is it traverses through each and every character in the given string and find out its ASCII value and adds all of them and does a modulus operation on that number and finally arrive at the final result. If you are not aware of what is an ASCII value of a given characters, here is a quick reference guide. So the ASCII value of uppercase A starts from 65 and increments by 1 as we go to next character. So ASCII value of uppercase A is 65, uppercase B is 66, uppercase C is 67, and so on. So in our algorithm, what it does is it takes this string, that is ABCDEFGH, that is 65 plus 66 plus 67 plus 68 and so on, and arrives at number 548. So once it gets the number 548, it divides it by number 16 because that's what we have given as divisor. So when we divide 548 by 16, we get 4 as remainder, which is finally displayed as the output value. This is once again a very simple example of how a hash function looks like. In real world, the hash functions are way too complicated, but the basics of it remains the same. So now that we have understood some sample hash functions, it's time to understand some of the characteristics of good hash functions. Now why do we need that? We need it because when we are going to solve some real world problems, these hash functions which we just discussed will not work because they are too simple. So we need to choose better hash functions, and hence we need to know the characteristic of good hash functions. So let's get to the next slide. So the first characteristic of a good hash function is that it distributes hash values uniformly across the hash table. Now what do we mean by that? Now let's say this is our hash function which is sASCII. Now let's say we are giving it multiple inputs to process. Now let's say this is the input that we are giving to this function, that is ABCDEFG KLMNOPQR PQRSTUVW. Now let's assume that after processing each of these strings, our ASCII function returns same value, that is 4 in every case. In that case, we'll say that this hash function is not good enough, because if it regularly gives the same output, which is 4 in this case, every time we try to insert this string in our hash table, we go to cell number 4 and try to insert it. But since there is already a data in that cell from the previous input, we always result in a state of collision. And to resolve a given collision, it is an extra overhead. So we always try to implement a hash function which distributes the cell numbers uniformly, so that we can avoid collision as much as possible. By the way, if you don't understand what is collision, don't worry. We are going to discuss about it in extreme depth in our next videos. As of now, just understand that a collision is a state which we try to avoid at any condition. Now the next important characteristic of a good hash function is that it should use all the input data. Now what does that mean? Now let's say we are giving an input to this ASCII function as these 3 strings. Now if this function always takes only say first 8 characters in a given string and ignores rest of them to arrive at the final output, then we have a problem. Say in this case, we have 3 different strings, but the first 8 characters in all these strings are exactly the same, that is ABCDEFGH. Now if our ASCII function only takes the first 8 characters, it will always result in number 4 in all the 3 cases, though the input string was completely different in all the 3 cases. So once again, we'll end up in the state of collision which we always want to avoid. Hence, a good hash function should always consider the entire string which has been given to it. With this, we come to end of this video. In the next video, we are going to talk about the important concept called collision. We'll also talk about how many types of collisions are there and what should we do when we encounter a collision. With this, we end this video. Thank you. See you in the next video.